we are going to talk through that video that we've just seen. And it says here in that text, when we're talking about vertical motion under gravity, it says, famously, when the Apollo 15 landed on the moon in July 1971, astronaut David Scott conducted a famous demonstration in which a hammer and feather were released at the same time. As anticipated, they hit the ground at the same time. We also saw in that video how it took longer for them to fall on the moon than it would do on Earth. And I said that's because the gravity on the moon is about a sixth, I think, of what the gravity is on Earth. So I've said here, if there is no air resistance, then the acceleration of objects under gravity, regardless of mass, is constant. Great. Constant acceleration means we can use these Suvat formulae that we have here. The downwards acceleration under gravity is 9.8 meters per second squared, okay? It is downwards. Things never accelerate upwards due to gravity, so that's going to be playing into some of the things we're about to have a look at next. And I've put an important note here, because people will be doing other subjects that may use gravity. It says, it is important that you use 9.8 and not 10 or 9.81, which is often used in other exam boards or in physics. If you do that, you will just lose out the accuracy marks because you haven't used what it will say at the beginning of the exam paper, take G to be equal 9.8 unless otherwise told. Also note that given that we're using the value of G to two significant figures, any subject value calculated should also be given to two significant figures. So that's why we do rounding, because we've already rounded the gravity constant, so we're going to have to keep everything else rounded like that as well. Now, before we proceed with this, I know there are people in here who do physics. You must listen to the way that I do this, because in physics, they sometimes will do 2 or 3 equations to do something that in maths, we just do it in 1 equation. So you must make sure, even if you're like, yeah, I know this, you probably won't do it in the way I do it, and you should do it in the way I do it, because it's more efficient, okay? So, we have here, a book falls off the top shelf of a bookcase. The shelf is 1.4 meters above a wooden floor. Find the time the book takes to reach the floor and the speed with which the book strikes the floor. And I have written here, it is very important you consider what direction is considered as positive and mark it next to your Suvat values. If up was positive, then A would be equal to minus 9.8, because if we're saying that up is positive, we know that the acceleration is down, so down must be negative. If down is positive, then A would be a positive 9.8, because it's going in the same direction that we've set to be positive. Which way you pick does not matter. Every single year I teach this, people start panicking and being like, but I set up as positive and this person has set down as positive. Aren't we going to get different answers? You will not get different answers. Okay? The formulae behave in a way that it doesn't matter which way you set as positive and which way you set as negative. So, for this particular one that we've got here, we're talking about a book falling off the top shelf of a bookcase. So here is my book. Everything is basically going to be a ball when we draw these things. And we know we want to find out when it hits the floor. They've told us when it hits the floor, we know that this distance here is 1.4 meters. We also know that it is accelerating downwards at 9.8. You may sometimes like to write that as G, depends on the context of the question. Do we know anything else about this? Because remember, you need 3 things to be able to find out a 4th thing. Good. We know that it's falling off from the top shelf of the bookcase. That means it's not being thrown downwards. It means it's starting off from rest. It's just starting with no speed at all, and then it's just going to be dropped. So we know a few different things here, and I think the best direction to pick for positive will be downwards. So I'm going to say downwards, and I'm going to put a circle around that to remind me that downwards is my positive direction. For this simple example, it's not necessary, but you have to trust me and know that when we go to more complicated examples, you're going to need that arrow to tell you which direction you've said. So we know that the acceleration is 9.8, and it's downwards, so it's going to remain as positive. And we know that its initial speed is 0 because it's starting. It's not being thrown downwards. It's just being released and dropped off the top of the shelf. And we know that the displacement is 1.4. The displacement from here to here is 1.4. Who remembers what's the analogy I say to try and think about displacement? I know this is a simple example. Good, like a picture at the beginning and a picture at the end. How has it changed? This one, it's easy just because it's obvious. It's just going to be a 1.4 downward, so it's positive. And we want to find out, first of all, the time for this to happen. So we're going to use S equals ut plus a half at squared. So we get 1.4 equals 0, because u times t when u is 0 is just 0, plus a half times a times t squared. So we get 1.4 is a half of 9.8, which is 4.9. So it's 4.9 t squared. So I'll finish off by solving that equation. I'll do 1.4 divided by 4.9, and I'll square root it to find out what the time is. And so you get time is equal to 0.53 to two significant figures. Yeah.
Just show your point. If that was negative, then we'll just do the same.
Yeah, let's do the question again. And this time we're going to say that upwards is positive, okay? So A would be minus 9.8 because it's going downwards. U would still be 0. What would S be equal to? 1.4 or minus 1.4? Minus 1.4 because it's gone in the negative direction, so it'd be minus 1.4. And we're going to find out what T is equal to. So this time we get S equals ut, which is still 0, plus a half a, which is minus 4.9 t squared. And so then when you get minus 1.4 divided by minus 4.9, that's the same as positive 1.4 divided by positive 4.9, and it resolves itself and comes out with the same answer for the value of time. Okay, good. Thank you for pointing that out, Muhin. It's good to see that happening that second time as well, that it still gives the same answer. So there's also another value for time, though. What's the other value for time? Plus or minus. There's also plus or minus here, but I didn't do the minus one because obviously time is going to be greater than 0 in this particular thing that we've got, okay? So we're just going to take that positive one that we've got there. Now, for the part B of the question, it says find the speed with which the book strikes the floor. So I'm now looking for, as it strikes the floor over here, that's the speed just before it strikes the floor. Sometimes people say, oh, the speed that it strikes the floor is 0. Why are they thinking that it's 0? Because they're looking at it after it's hit the floor. They're looking at it and saying, well, it's not moving, so the final speed is 0. But that's not what we're asking about. We're asking about when it's that high off the floor, when it's like a millimetre off the floor, even smaller than that, how fast is it travelling then, before it stops, okay? So for part B of the question, we're trying to find out now what V is equal to. Which equation do you think is going to be best to use? Yeah, because what if we made a mistake with T? If we made a mistake with T, then we're going to get V wrong as well. So I think we're better to use A, U, S, and V, which is V squared equals U squared plus 2AS. So we get V squared equals 0 plus 2 times 9.8 times 1.4. So V will be the square root of this that we have here. So that's 2 times 9.8 times 1.4 square rooted. And we get 5.2 meters per second, so two significant figures. When it's done with G, it should be two significant figures. I've said down here, only two significant figures. You may be penalised if you quote more, because G has already been rounded to 2. Okay? There are some random questions where it will say, in this question, take G to be equal to 10. So if it asks you that during the question, you just have to keep everything with G as 10, but it will tell you that within the question. If it doesn't tell you, 9.8. If it does tell you, make sure you use the one that it uses. Probably 2. I'm not 100% sure on that. I can't say, but it should be 1 really, shouldn't it? So here, there is actually 2 values of v. The other value of v is minus 5.2. But in the context of our question, we were expecting v to be positive because we know it was moving downwards. Okay, so we know that it should be moving downwards there. Can I go on to the next slide? Okay, so turn your pages over. So this is, I'll turn the lights off for this bit. This is a video of me on a beach in Wales throwing a stone up in the air to help us with this question. This is from a few years ago. So we'll have a talk through that in just a second. Unfortunately, obviously, your printed version is not moving. And this moving image is to illustrate the point that sometimes it's really hard for people to imagine. Some people can imagine this, some people can't imagine this. But it's this little bit I've got in the blue box here. When something is moving under gravity, when it reaches its maximum height, its speed is 0. Just look what happens to that stone when it gets to the top. It like stops moving. It's just kind of like rotating around. And then you can see what's happening as it starts moving down. It's getting faster and faster. As it's going up, it's slowing down, isn't it? It's slowing down until it gets to the very peak of its journey. And at the peak of its journey, it's not moving at all. And then it starts to go back down again. So it's constant acceleration downwards. As it's moving up, because it's accelerating downwards, it's slowing down. As it's moving down, because it's accelerating downwards, it is speeding up. This whole thing can be considered as one journey. I've heard of people who have studied things from GCSE or from A-level physics. They go, well, obviously the journey up is going to be different to the journey down. No, the whole thing has an acceleration of downwards 9.8. When it's moving up, it's slowing down. When it's moving down, it's speeding up. So we're going to now use this little visualization to help us what's happening here. And it says a ball is projected vertically upwards from a point X, which is 7 meters above the ground, with speed 21 meters per second. Find the greatest height above the ground reached by the ball and the time of flight of the ball. So I'm going to draw a little visual diagram that might help us think about some of these things that are happening here. And it's being projected from this point here. And this distance is 7 meters above the ground. And it's being projected upwards with a speed of 21. The journey of this ball is it's going to come upwards, and then it's going to come down, and it's going to hit the floor. Okay? The first thing that we're interested in, though, is to note the greatest height above the ground that the ball gets to. So I'm going to do this first question, which is from here to here. I'm going to do that first bit will be in red. I'm also going to add onto my diagram that it has acceleration downwards of 9.8. And we're just going to start grabbing the different values for part A of the question. So which direction, and it really doesn't matter, up or down, do we want to make it positive in this case? We'll do downwards. Okay, it really, really doesn't matter. So I'm going to say that downwards is positive, and we're doing the journey from here to here, okay? So if downwards is positive, what's the value of u? Minus 21. Because we've said this is positive, and this is clearly going in the opposite direction to that. So the value of u is minus 21. What's the value of the acceleration? To mean? Good. The acceleration is going downwards, which is positive. So the acceleration is 9.8 because it's matching the direction. We are interested when it reaches the greatest height. What can you tell me about the red dot here? The speed is 0. It's just like in my video of me throwing the stone here. At the top, its final speed is 0. And what value do they want me to find? They want me to find S. Now, S is going to tell me between this snapshot on my camera and this snapshot on my camera. But the question wants it above the ground. So what do you think I'm going to need to do afterwards? I'm going to need to plus 7 to it because it's only going to tell me the distance from the beginning of my snapshot to the end of my snapshot, okay? So we're going to find out what S is equal to. The things that connect U, A, V, and S is V squared equals U squared plus 2AS. So we get 0 equals minus 21 squared plus 2 times 9.8 times S. So we get 21 squared, minus 21 squared, sorry, so you get 441 plus 2 times 9.8 is 19.6 S. I'm just going to give you a chance to get that bit written down because this next bit's going to be really important for you to listen to. Tell me about S. It's going to be negative. Is that a bad thing? Why is that not a bad thing in this particular case? What do you think, Ishak? Why do you think S, it's okay that S is negative? Not sure? Pardon? We took the downwards direction as positive. From our snapshot in our camera, from here to here, it's moved in that direction, and that direction is negative. So if we didn't get a negative answer, we would have been frustrated. We wouldn't have had a clue why that was happening. So when you solve this, you get that S is equal to, what's that, 441 divided by minus 19.6. You get S is minus 22.5 meters. Now remember, minus 22.5 meters, it's saying, oh, it's going 22.5 meters in the negative direction. Well, if that's the positive direction, it's going 22.5 meters like that. So the distance above the ground will be 7 plus 22.5, which is 29.5 meters, which is 30 meters to 2 significant figures. And if we go back to Muhin's question, what about if we changed all of these values here? If we said that upwards was positive, what would happen to U? It would be positive. A, minus 9.8. V would stay as 0. What would you expect S to be at the end? Positive, because we've said upwards is positive direction. So it's completely dependent on the way that you do this, okay? Now we're going to do part B of the question, and part B says, find the time of flight of the ball. What do you think the time of flight of the ball actually means? Good, it's the time from where it is here to when it lands here. So we want to know the entire time of that journey. This is the part where, and I've seen people who have done physics, is they go, oh, well, I'll work out the time from here to here, and then I'll work out the time from here to here. But that is not required, that is not necessary, and is way too much work because the formula will do all of this work for us. So we're going to just ignore this red bit. We're just going to look at the beginning and we're going to look at the end. We're going to imagine it like a photo that's been taken on a camera, okay? We know which direction do you want to take as positive. Should we do downwards again? Yeah, because we've got quite a few things that maybe will be going downwards. So we're going to take downwards as positive, which means that my acceleration is 9.8. The initial, when we're looking at the blue section, we're going from the blue to the purple here, well, the initial would be minus 21 because it's going in the opposite direction, it's going upwards. And what else do I know? S, what is S equal to? S is equal to 7. From here to here, it has gone downwards 7 meters. Snapshot at the beginning, snapshot at the end. I don't care that it's gone up like this, it could have gone whatever. All I care about is where it is and where it was, and what's the difference between them. Why is it not minus 7? Because we've said that downwards is positive, okay? And the thing that we want to find out is what t is equal to, the time of flight. And the things that connects these together, s equals ut plus a half at squared. So we get 7 equals minus 21t. A half of 9.8 is 4.9. So you get plus 4.9 t squared. make it look like a quadratic. So you get your 4.9t squared minus 21t minus 7. And we do that on our equation solver. So you get 4.9. So S is 7. First thing you need to notice is we've decided that downwards was positive. At the beginning, it's here, and at the end, it's here. So if you imagine you were only provided a photo of it where it was at the beginning and where it was at the end, you would tell me, ignoring its journey, it has moved down 7 meters, which means that you would say it's moved, the displacement is 7 in the downwards direction, which is positive. Okay? People don't like the fact that we're ignoring the fact that it went upwards for the displacement, but remember, displacement is different to distance. If they asked for the total distance it travelled, you would have to find out that distance and find out that distance, but they rarely do that. They rarely just want to just use this kind of fact here. Okay. What have we got for the values then, using the equation solver? Good, so we can go straight in. We can say that t is equal to 4.6 to 2 significant figures, or t is equal to minus 0.31 to 2 significant figures. Now, this is something that, if you don't want to listen to this, it might be a bit abstract for some of you guys here. But the minus 0.31 does have a significance because the equation doesn't really know what's going on here. All the equation is talking about is things that go up and things that come down again. This minus 0.31, and if this confuses you, just ignore it because it's not going to make any difference to you. It's almost like if the timer started here, we've said it takes 4 seconds to do that bit, okay? If it actually started down here and it got shot upwards, and as it passed through there it had 21 and it came like this, it would take 0.31 seconds to get to that stage and then 4.1 seconds to get that stage. But it's almost like we've said that the starting time here is 0. The equation doesn't know it's starting on the top of a cliff or wherever it is, starting on the top of a platform. The equation just thinks it's a quadratic. So although it's not going to be useful for us in this question, it does have a significance. It tells you that the journey time from here to here is 0.31. And because it's symmetrical, the journey time from here to here is also 0.31. You will rarely need to use that, but it does have a meaning. So because t is greater than 0, we know that t is equal to 4.6 seconds. And this is all I've said here about taking the photo at the beginning and the photo at the end to try and think about what its displacement is, that it is not distance. So I think we're going to just do one more question, and then it's just going to be practice for the rest of the lesson. So I know you've been listening to me for a while now, but we're just going to do this one last question that we've got here. It says a ball is projected vertically upwards from ground level at a speed of 20 meters per second. Determine the amount of time the ball is at least 10 meters above ground level. So I'm going to draw a quick diagram of what's happening here. We have the ground. We have something that is being projected upwards. And then it comes back down. And we want to know how much time it is at least 10 meters above the ground. So it's being fired off from the bottom. It's going to go all the way to the top when the speed is 0, and it's going to come back down again. And I want to know how long does it stay above a certain height. And in this case, it's going to be 10 meters. I'm going to add on to my diagram to remind me that acceleration is downwards at 9.8. And I want to try and start picking out the different values that I've got here. Red one, can you tell me, I probably should have added this is 20. Can you tell me out of S, U, V, A, and T, any of the values that we know about? And before that, which direction do you want to take as positive? Okay, so we can take that as positive. I don't mind which you pick.
So the displacement. 10.
Yeah, it's going to be a positive 10 because we're saying I'm interested to know when the ball gets here and when the ball gets here. Okay, anything else? So you've got S is 10?
Well, that
Good, and it's a positive 20 because it's going in the upwards direction. Nabil, any other values you can tell me about?
The speed is 20.
We've got the initial speed is 20.
Final velocity is like 1 knot.
We don't know the final velocity, but there's something else we haven't used yet. Zishan, can you spot what else hasn't been used? What's the acceleration? Minus 9.8, okay? Minus 9.8 here. So if I want to find out something to do with the amount of time that the ball is above that bit, I'm going to calculate how long it takes to get here, and I'm going to find something else about the time as well, and we'll just try and figure out what's happening. Quick side note, just because acceleration in these questions is 9.8, it does not mean that the acceleration now is always 9.8. Sometimes people now just go like, oh, well, obviously acceleration is 9.8. Acceleration is only 9.8 if something is free falling. So the equation that connects these together is S equals ut plus a half at squared. So S equals ut, a half of a is minus 4.9 t squared. Why do you think I'm happy when I see this? What type of equation is it? It's a quadratic. And a quadratic is going to give me, hopefully, two answers, which will refer to the time when it gets up here, and then tick, 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 the time when it gets here as well. So hopefully it's going to give me two answers. Well, it is going to give me two answers, not hopefully. So if I rearrange this, I might as well leave it on this side. I've got minus 4.9 t squared plus 20t minus 10. Get our equation solver. And you've got your two times. Now I'm going to not round them just yet because it's not my final answer. So I've got 3.498 and I've got 0.583. So I'm going to call this one T1 and this one T2 because I've got two different times now. And they refer to T1 is this bit here, which is 0.583. It's that time that we have here. T2 is this time when it gets here, which is 3.498. Good, yeah. So just to think about what the times are in this particular situation, the time when it is here is 0, and it's like a clock that's running. It takes 0.583 seconds to get here. Tick, 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 tick. The time is still going on. When it gets to here, the timer now says 3.498, and then it's going to take a bit more time for it to get here. So the amount of time that it spends above this blue line is found by doing the difference between those times. Because if it takes 3.5 seconds to do all of that, and 0.5 seconds there, the amount of time it's in between when it's above that line will be the difference between those two times. So we can say time above 10 meters is T2 minus T1, which is this one, take away this one. So you get 3.498 minus 0.583, and you get 2.915, which is going to be 2.9 seconds to two significant figures. That's the bit that people sometimes find hard, but it's like a clock. At the beginning here, time is 0.
So time is going up.
Time has no direction. These little bits where I've got the times, it's almost like someone stood at the beginning with their watch and they had the timer was at 0. And when it passed through that point, their timer said 0.583. And when it passed through that point, their timer said 3.498. Who thinks they could predict what they think the time would be down here? You could add that time, because we know that's how long it takes to go up there. It's actually going to take the same amount of time for it to come back there, because it's symmetrical. So you would take that time, and you would add on that, and it would give you the time that it gets to the end. So 3.498 plus 0.583. That would be the time for it to end up that whole journey. But yeah, Muhin, you're right. This is going to be quicker here, but it's going to be the same as this amount of time. because it's completely symmetrical. If you wanted to do a Suvat equation to find the time from here to here, this is my last question before we go and do practice, what would the displacement be from the start of the journey to the end of the journey?
0.
Are you sure? Yeah. The start of the journey to the end of the journey, what's the displacement from here to here? 0. Imagine if you saw a picture of it here and a picture of it here, you'd say it hasn't moved. So you would say that S is equal to 0. And I guarantee if you did S equals 0 with U as 20 and A as minus 9.8, I guarantee you would get the answer 0 and you would get the answer whatever this thing is here. Okay? So you're going to do exercise 9E, you're going to do the even questions. We've got a good amount of time to do this. And then on Thursday, we'll do a little bit more practice and then maybe a kind of end of term quiz.